All right, we are going to solve equations that have absolute values in them. We're going to start out with a rule. It says if we take the absolute value of an unknown, we'll call it x, and it's equal to a number, we'll call it a, then we actually have two options. X is going to equal a, or x is going to equal negative a. This is easy to take a look at with an example, so we'll just jump right off with that. Our first example, we're going to have the absolute value of x is equal to 5. Well, this equation is easy to solve. That means that x equals 5, or x equals negative 5. And those are my only two options. The reason is because if I replace the x equals 5 into the equation, the absolute value of 5 is 5. If I replace negative 5 into the equation, the absolute value of negative 5 is still 5. So both are viable answers. Let's try this next one. We'll have the absolute value of 2x minus 3 is equal to 5. So my two options are that 2x minus 3 is equal to 5, or my second option is 2x minus 3 is equal to negative 5. Now I have two equations to solve. On the first equation, I'm going to go ahead and add a 3 to both sides. I get 2x equals 8, which means that x equals 4. My other equation, I'm going to go ahead and add a 3 to both sides. And I get 2x is equal to negative 2, which means that x equals negative 1. I now have two answers. X is 4, or x is negative 1. Remember, with these absolute value problems, you're always going to have two answers. Our next example. What we need to do, according to the rule, is we need to get the absolute value by itself. So in this case, we're going to have the absolute value of 5x plus 9 equals 19. So I need to isolate the absolute value first, so I'm going to go ahead and subtract the 9, so I get the absolute value equals a number. So I get absolute value of 5x is equal to 10. Now my rule comes into play. 5x equals 10, or 5x equals negative 10. And now I'm going to solve each equation. The left one I'm going to divide by 5, giving me that x equals 2. My other option, when I divide by 5, it's going to give me that x is equal to negative 2. Again, we have two answers. Our next example is the absolute value of z is equal to 0. Well, my two options are z equals 0, z equals negative 0, but negative 0 doesn't exist. So in this case, the only option is if z is equal to 0. When it equals 0, that's the only scenario where we only have one answer. Our next one, our last one actually, is going to be the absolute value of 7x minus 5 over 4 is equal to negative 3. Now I'm going to stop us right here. When I take the absolute value, I can never have it equal to a negative value. The definition of absolute value is always making it positive. So even if I wanted to do the negative case or the positive case, it doesn't make any difference. The absolute value can never equal a negative value. So in this case, there is no solution. And we represent no solution with a circle with a line through it. That stands for the empty set. That's not 0. So not to be confused with the previous example where z equaled 0. This literally means no solutions. And there you have it.